Hello, everybody. Hello, AI Camp. All right, everybody wave at me. Hey, Jim. How many of you guys have seen me before? Many of you have seen me before, yes. I'm famous. That's true. I am one of the famous people in Seattle, next only to, I don't know, Bill Gates. He's pretty famous. All right, as people kind of start trickling in, I'm just gonna start saying things into the mic. Find a place to sit when you, find a place to sit, sorry. When you get in, please don't stand by the wall over there. You're blocking a very nice image of the Octocat. All right, welcome everybody to the, what month is it? September version of this meetup. I thank you for laughing. That was actually not meant to be a joke. I just actually forgot what month it was. Okay, this is like reverberating. How do I? How am I like turning this? Oh, turn it on. Okay. Okay, that's much better. Okay, that's weird. Not as weird. Okay, cool. So a little bit about AI Camp. How many of you guys have been to an AI Camp meetup before? Raise your hand. Okay, about like 30% of the room. So for those of you who haven't been to an AI Camp meetup before, AI Camp is a huge global organization of over 400,000 developers in over 150 countries. The AI Camp founder is back there. Bill is walking around, and he's based in Seattle. So AI Camp is based out of here in Seattle. And that makes Seattle one of the best AI spots in the country. So congratulations. If you are... I really appreciate the enthusiasm. That's amazing. Other chapters include SF, New York, Boston, Toronto, you know, these like lesser cities. If you are interested in getting involved and doing this kind of stuff and showing up on occasion and just randomly hosting and coming up here and speaking on stage like me, you can join the community builders team by emailing info@aicamp.ai. If you have other things that you would like to do, such as speak on interesting topics in AI or sponsor the meetups, you can also, info@aicamp.ai. Other things that AI Camp does includes a virtual weekly seminar, these monthly meetups, and our next workshop or boot camp, whatever, is going to be October 2nd. I actually think there's one on September 19th. Bill is not in the room to confirm that, but I think there's also one on September 19th. October 2nd, we'll have another meetup here. And when is the AI Hackathon? Is that the one on the 19th? Okay, day is not decided yet. Here are some of our other sponsors. And, oh, yes, oh, I love this part. So is anybody here looking to hire? All right, nobody here is looking to hire. Okay, is everybody here looking for a job? Okay, many of more of you are looking for a job. Okay, so this is like one of those things where actually normally I would be like, if you're looking for a job, you should talk to the people who raise their hands when I asked who was looking to hire, but I don't think that's gonna work out for this one. If you would like to join the Slack or the Discord, you know, take out your phones, scan these QR codes, you know, get in there. Is anybody looking for any projects, working on any projects where they're looking for collaborators or anything like that? Okay, so we've got a few people. I think actually this would be good to chat about.
Not yet? I saw you raise a hand.
Anyone else want to say anything about projects they're working on? Nobody wants to announce any projects they're working on? Okay, so you guys suddenly got very shy. Yeah, so for this event, thank you to our sponsors, GitHub, of course, where we are right now. Pieces for DevRel. We got Jim. Ah, there you go. That's how you get people to clap for you. Weaviate. You're from Weaviate? Okay, there. Weaviate's over there. He's got a Lego bag, so I think he's got some prizes. I don't know. I don't want to make people too excited here. And Quadrant Technologies, they've got that little thing over there. And actually, I think this is also a good plug for you to just say, like, if you are looking to get hired, you should go chat with those guys back there. Raise your hands. Wave. There you go. We'll play a little video about Quadrant as well. It's like a hype video. Uh-oh, where's the sound?
Technologies has carved an extraordinary path in the IT landscape over the past 2 decades. With an ambitious vision, this cloud, data, and AI powerhouse has rapidly scaled from a small business to a formidable enterprises, expanding its global footprint across 13 countries, 20 locations. Quadrant's diverse team of over 3,000 professionals delivers a comprehensive suite of services, from cloud operations and AI-driven innovation to data analytics, serving a wide range of industries. Quadrant's impressive accolades, including rankings among the fastest-growing companies and top workplaces, attest to its unwavering commitment to excellence and adaptability. Embracing evolving market needs, Quadrant provides tailored solutions with transparency and honesty, while being deeply rooted in social and environmental responsibilities.
All right. Yes, very good hype video there. Well made. Who's our first speaker? John, Weaviate? Weaviate!
Testing 1, 2. Yeah. Okay. How's that? Is it a little echoey? Echo. Try this one. Hello. That's better. Okay, I could drive with one hand. That's good. 1 second. Let me just get logged into the Zoom. I think I got disconnected from the Zoom. Hold on 1 second. All right, I think we're cooking with gas now. Let's go into slideshow mode. All righty. So today, we're going to talk about building a RAG without having to code a user interface. How many people here have built a RAG from scratch before? Yeah, that's what I thought. Quite a lot of you. So we're going to talk all about how you can do this the most easiest way possible without having to focus too much on the UI. So before we get off to start, I'll start with an introduction. We'll talk about challenges with this kind of development, creating these UIs. We'll talk about the solution, which is a low-code app builder. Then we'll get into a live demo and finish up with next steps and questions. So before I get going, you guys like Batman? I have this really cool Lego Batman. My son loves Lego and Batman, so that's why I got this one for this show. But if you scan that QR code right there, enter in your information. At the end of this presentation, I will do a drawing, and I found a really cool little app that'll help me do that. And you will get this tonight. So there's the QR code. You'll see it again at the end if you don't want to do it right now. But let's go on. So a little bit about me. I've been doing this for about 18 years now in the data analytics space. I actually started in the video game industry, building BI platforms to understand how people play games, what what skills are they using, that kind of stuff. And it eventually led to me kind of working in the SaaS industry. Started off at Click, went to Splunk, Snowflake, Rockset, and now I'm at Weaviate. So a lot of different SaaS vendors, kind of understanding data in the cloud. And I have a real passion for kind of unlocking the value of data, whether that's structured data, unstructured data. I love it. I love it. This is what I geek out about. So I'm really excited to tell you about this really cool way you guys could build RAG applications. So I have a ton of hobbies. I do stuff all the time. One of them is beekeeping. And this is a picture of me in Kenya working with killer bees. You can see they are very angry. So I'm not going to go too much into that, but that's a little bit about me. Just wanted to start off with that. If you want to talk about bees or vectors after the show, please come find me. I will talk all night about bees. So let's move on. So has anybody ever seen this before? And no, I'm not talking about his mustache. I'm talking about the car. The car is a Model 770 Amphicar, and it was designed to run both in the in the water and on the land. And they called it the 770 because it was supposed to go 70 miles an hour and 7 knots in the water. It went about 50 miles an hour and 5 knots, so they should have called it about the 550. But it wasn't very good at either one of the things that it was trying to do. Instead of just focusing on being a car, it focused on being a boat and a car. It didn't really do either one very well. Another example, the spork. Have you guys ever tried to eat soup with a spork? It's impossible. You can't do it. Picking up large things with a spork, also can't do it. Those tongues are too small. It doesn't work. So another one, this last one, you get what I'm getting at, right? Another one, the floating bike, it's ridiculous. Doesn't do well on the land or the water, right? So the point of what I'm kind of getting at here is UI development and data engineering are two separate things. You shouldn't have to do both, right? So don't focus on the UI, focus on what you love, focus on the data. That's what I'm here to talk about today. So as I said, these are two very different skill sets. You can see from the IDEs designers use to the ones data scientists use, very different. The types of data they work with, JSON versus images. Languages are different, data sources are different. Everything is very different in the design world versus the data science world. So there's some people that can do that little sliver in the middle really well, and good for them. But most of us focus on one of these circles typically. So some of the challenges that I've run into, that I've seen other people run into, mostly revolve around speed. I mean, you have to have a UI for a RAG application. You need to have a way to interact with the data, send in queries, get results, display those results. So you need a way to also prototype quickly, because we're all figuring this out. We're all figuring out AI, RAG, vector databases, we're all figuring this out. So we need to be able to rapidly prototype in this phase. So some organizations have UI developers available, and that's great, but that's not always common, and it will slow you down if you have to wait for another developer to build your front end for you. So the other part of building a front end is that it's got to be intuitive. So if it doesn't make sense how to use it, your users are not going to use it. So you need to still have that designer eye for your applications, but you may not necessarily need the designer. Some of the complexity that I've seen is, coding itself, learning multiple languages, understanding how those languages interact with one another. Each data source that you work with, whether it's Weaviate or another one, we all have our own libraries, right? We all do different things through code in different ways. So you're going to have to learn each library and how to interact with it. Graphic design is not easy. It doesn't come intuitive for people who typically work with data like myself. And then finally, the web server management, creating a React server is awesome. I've done it myself a few times, but it can be such a pain to have to manage over time. Libraries get out of sync. It can be very frustrating. And then you have scaling. How do you scale that UI up alongside the data? Those are two different scaling problems that you have to solve. Updates, additions, the changes to the library. Sometimes, oh man, I can't tell you how many times my node.js gets out of sync with applications that I try to run. It can be very, very difficult and, again, very frustrating. Also, being able to sync with source control is incredibly important. If you do design a UI, it needs to be synced up with a source control so that multiple developers can work on it and it's in a safe place. So all these things kind of lead up to using something called a low-code application builder. So there's several of them out there. They're usually SaaS products like Superblocks, Retool, AppSmith. There's some open source as well. But what these do is they take away that hard part, all those things I just talked about, all those challenges. They allow you as a developer to build a UI without having to code a UI. It's a low-code environment, which means that you'll see it in a minute, but it basically just means that they take away a lot of the basic coding requirements that you might have in like a React application, things like that. So they basically just make it easy for anyone, whether you have a coding background or not, to build out an application. So it's out of the box. It's got a bunch of integration capabilities, so it can connect to, HubSpot if you want it, Weaviate. It can connect to almost anything out there that has an API. Very powerful, and it's all in like one easy to use kind of environment. It's a lot of drag and drop, resizing things with the mouse, writing simple just dot notation for JSON references. But beyond that, there's not much coding involved. It makes it very, very quick and easy to use. So if you got the front end figured out, obviously now we need to talk about the back end. That's where Weaviate comes in. I'm from Weaviate. I've been working at Weaviate for the past year, and before that worked with various chatbots and kind of various different side projects. But I got my hands on Weaviate even before I joined the company. Really enjoyed it. It's a great user experience. They have a really cool DevRel team that goes out there and does tons of videos and kind of really teaches you the basics of creating RAGs. So with Weaviate, obviously we're very secure and flexible. We're open source. You can install us anywhere you want. You can install us yourself. You don't have to pay us a single dime. All the code that we use for our own SaaS is the same code you can download off our repo. So we do have a SaaS. We do have a SaaS offering. With Weaviate, you get multi-tenancy right out of the box, which is very important. If you have a massive use case where there's just tons of tenants that may or may not be online at any given moment, being able to control those tenants, turning them cold, hot, or warm, very, very powerful. We could do that at Weaviate. The other important thing is being able to search a lot of different ways. With a vector database, everyone knows that the typical way you search is semantic search, vector search, right? Nearest neighbor search. So we have that, obviously, but we also have hybrid search, which combines keywords with that. If you do a semantic search, you're not always going to respect actual word-for-word keyword matches, right? It's more about semantics and where the vector lives. I'll talk about that in a second. But being able to do that hybrid search where it combines the vector search and the keyword search is extremely powerful for any RAG application. I would only recommend hybrid for RAG applications. Generative search is the idea of just taking the results of a vector database and then just automatically plugging it into the prompt for you so you don't have to do it. And then filtered search and aggregate search are pretty obvious. And then finally, GraphQL. This is actually one of the most important because this is how Superblocks is going to interact with Weaviate. We're going to use this GraphQL connector. So again, a little bit about this is the typical sales slide. I'm not going to spend a lot of time on it, but we are a real company. If you haven't heard of us, we have a lot of different customers. Founded in 2019, and for our open source, we have over 13 million downloads. So a lot of people like to get the value out of using Weaviate. So let's just take a step back. For those that don't know what a vector is, I'm just going to do a really quick basic explanation. What you do is you take your data and you turn it into a bunch of numbers. And those numbers will look similar to what you might know as the color code system, the RGB system, right? And if you were to take that RGB system and you plotted it, it would look something like that. And you can see there's a natural grouping of the different colors. So each of these points represents a color. It has meaning behind it. This is the exact same thing with any vector you use. Except if you were to use Ada, which is the OpenAI model that will turn your data into a vector, instead of looks like 4 dimensions there. Instead of, we'll say it's 3 dimensions there, you have 1,536 dimensions. So I can't even imagine what that would look like. So it's kind of mind-boggling. We can't actually visually draw it, but we can get an idea. So data becomes vectors, and vectors show how things are related, which leads to a vector search. So when you plot everything on this multi-dimensional chart, and this is what Weaviate does, and you do a search, say I'm searching for a banana, it's going to return back apple, because apple is close to banana in this multi-dimensional space. Dog, wolf, and cat are way over there. They have nothing to do with bananas. So when you do a vector search or nearest neighbor search or similarity search, it's all pretty much the same thing. This is what you're getting. It's just finding out what vectors are close by. So this is what Weaviate does. So when you combine them together, you get a really cool combination. You enable Google-like search on any piece of your data. Semantic data retrieval becomes a reality. So we take away the UI with Superblocks. We connect it with GraphQL. We take advantage of the pre-built components so we don't have to build them. We take advantage of the automatic vectorization that Weaviate does under the covers. And then for things like RBAC and authorization authentication, we can use Superblocks to do that. So here's a couple examples. So this is an e-commerce app I built, and this took me roughly about 4 or 5 hours to do. Not too bad. It was one of my first attempts, actually. It came out really well. But it's very, very powerful. I use this a lot in demos because it shows how I can do the different searches up there in the top left. With the search type, it's just an easy drop down to change. But this kind of shows an example of a semantic type search, searching on products, right? Warm winter clothes. This is a RAG demo that I built. This is kind of similar to what you'll see in a minute. And again, this took me probably about 30 minutes to do. It's not as pretty as the other one. But you still have this chat bot down there at the bottom that you can like literally chat to your data. So this only took me, like I said, about 30 minutes to build. So it's demo time. You guys ready? All right. So what we're going to do is we're going to set up a connection. I've actually done a lot of the work already. We have a limited amount of time here, so I didn't want to spend a bunch of time doing development. But I'll show you how I did. And I'll show you how I set up the connection to Weaviate. We will actually drop in a chat box. So I'll do that. And then we'll kind of configure that chat box. Sorry? Sorry? For Weaviate, yes. If you want to use our cloud, you can sign up. If you want to install it yourself, you can just use a Docker container, install it on your laptop. That's totally fine. Either way will work. But at the end of the day, you just need a URL and an API key. You get that, you're off to the races. But I'll show you that in a minute. But what we're not going to do in this demo is set up a new cluster and load the data into Weaviate. If you are interested in that, next week, we're actually having a roadshow here in Seattle. I unfortunately will not be able to be there, but the rest of the team will be there. And it's a full day dedicated to kind of showing how to use Weaviate, how to get the most value out of it. Highly encourage you guys to sign up and join us. You can come for part of it, all of it, totally up to you. I'll put on a QR code at the end of this so you can sign up for it. But let's get into it. So, gotta stop sharing. Thank you. Okay. I lost it. Shoot. And put this down again. Okay, done. Come on, Zoom. I'm trying so hard to find this window. Okay, there it is. Okay, so I'm going to go over here. All right, so this is Superblocks. So we're going to just do it. Okay, so this is the development environment of Superblocks. I'm in development mode right now. There's a non-development mode where you can't see all these properties and things like that. So the first thing I needed to do when I came in here was to set up the connection into Weaviate. And as I said earlier, we're just using a GraphQL connector. This is where you would put your API key. Question in the back. Sorry? Yep, exactly. With Weaviate, we can connect to pretty much any LLM you want. In this case, I'm just using OpenAI. So I'm providing it my OpenAI key that allows it to do both vectorization as well as send the results to the LLM for me automatically to do what's called a generative search. So this is how you set up a connection. The important thing to note here is the V1 GraphQL endpoint. Everything else is your standard URL, but I add that on the end, provided the API key or bearer token, and then that's it. Once you create that, then you can, within the application environment, or sorry, development environment, you can now access that. So if I hit this button here, scroll down, scroll down. Sorry? You could do anything within Weaviate using GraphQL connector. So anyway, here's the one I'm using right here. I already got one built. If I was to set up the GraphQL syntax itself, just so you guys can see what it looks like. This is the get. I'm doing a hybrid search. I'm providing it an alpha value, which is like the higher it goes, the more it goes into a vector search, and then the lower it is, like a 0 is a pure keyword search. So in the middle is kind of halfway between. This is variable, so I'm actually using one of the components from the UI. So depending on which one you pick is what goes in here. So if I look at this component right here, you can see here I've hard-coded in the values for semantic, hybrid, et cetera, and you can see the values I put in there. So, get a little bit of feedback there. So when you first set up the application, you can create these connections. I have another one here that will send the data to the chatbot, to ChatGPT. So with this one, it's pretty easy to set up. You basically just point it to what you want to use for the prompt, again, a variable, and what you wanted to use for the message history. The message history is what sets essentially the system prompt for it. And I set that within a variable within the application. So you have concept of front-end variables that you can temporarily set. So for this one, I set it like this, setting it to be a system prompt and tell it the instructions I want it to follow. So I've got my system prompt, I've got my connection to Weaviate, and I've got my stream, which is this part here. Within the stream, I'm sticking in the ChatGPT component there. So the only thing left, and the only part of the demo I'm going to do live, is to actually stick in the chat bot. So within the components here, if I just type in chat, I'm just going to drag this out like that. So it's got a bunch of placeholders there. That's why you're seeing chat already, right? And I'm actually going to have to put the mic down, I think. There we go. Okay. So what I'm going to do now, okay, let's be quiet. I'm going to be quiet, talk quietly. So what I'm going to do is configure this component. So if I click on it over here, we got the message history. And again, this is all hard coded, but I'm just going to grab some code real quick. So what this is doing is kind of making everything variable. So I'm using my variable for
Sorry,
chat.
actually, some echoes.
Feedback?
Yeah.
Oh, yeah, for the recording. Okay. I'll try not to make weird noises. All right. So just to kind of wrap up, produce better results. Be a fork, don't be a spork, right? Uh, it'll make you faster. It'll make you more scalable, more functional, and give you more capabilities, like adding charts and graphs and stuff into your RAG, and make you more efficient as a developer. So highly recommend using this combination of things. And any other questions? I know we had a couple already. Yes. Sure. So let me see if I understand the question. You want to essentially kind of inject additional information into the RAG prompts. Is that right? Yeah. We have this concept known as a generative feedback loop, which is kind of like the next level of RAG, of where you're doing exactly that, where you're taking your data, your base data, you retrieve it on demand, and then you send it to an LLM, you augment it, you add things, you look specifically for things in the text, then you add that to the data, then you throw that back into Weaviate again. Right now, you've augmented your data, you've added more, you've increased your recall, your precision by adding more information into what you already have, right? And you can do that with an LLM. Different database from a data lake or data warehouse. Yeah, GraphQL is a language. We didn't come up with it. It's just it's kind of standard language out there for talking mostly with graph databases. But we've implemented it as well to interact with Weaviate. But it's not the standard way you interact with Weaviate. Most people use our Python client. It's a lot faster. It's also the Python library has a ton of really great features to make your life a lot easier. GraphQL, I find it very difficult, frankly. I'm a SQL guy. I love SQL. I know it all day, but writing GraphQL, it's very hard. But luckily, we have great documentation that can help guide you. Any other questions? Yeah.
So I'll recommend. Oh, sorry. You say you recommend hybrid search for RAG. Could you explain a little bit about
Sure.
that?
Yeah. As I said, hybrid search takes into account the keyword, right? So if you type in an exact keyword, the results you get may not be what you expect. You may not get that match as the first result, because it goes down to the vector and what's close by, and not the way you type things in to match a keyword doesn't always match up semantically. So I always recommend for hybrid search, the way that they interact with chatbots is they do a combination of keywords and just natural language as well. Like sometimes you write shorthand, sometimes you write longhand, and what you want. So that enables the Weaviate to find what you're looking for either way. Yeah, if you have your data in a data warehouse like Snowflake or Google or wherever, there's a ton of them, Redshift. Those you would integrate with Weaviate. You would find out what data you want from them and load it on a schedule to sync it with Weaviate. Now Weaviate has a copy of it, and that will enable your semantic search.
So,
Yes.
so
Yeah.
compared to the semantic search, does the hybrid search kind of speed up the process? Or is that another merit, or is it like actually like retrieves more relevant documents?
Sorry, what was the first part of that? Sorry.
So like compared to semantic search, what's the advantage of hybrid search? Like, is it like
it's more natural language. It's more how people search for things, rather than pure semantic. Doesn't always work the way you expect. is what I found. So hybrid's kind of that happy medium. No, there's well, okay. Let me rephrase that. It's smaller scale, no, but at the larger scale, yes. And the reason is because we're using an inverted index with a BM25 search on it, and that at scale slows down. So it's not the semantic search that slows down a hybrid search. It's actually the keyword search part of it. So I'm not sure on that one. Yeah, I'm not sure.
Okay, sure.
Any other questions?
I think we are probably out of times for
Oh,
the
yes,
sessions,
sorry.
and
Let me
but
just
we're going to
wrap this
have
up.
more. We're going to have more Q&A times after the next talk. Rita. Wait,
Can
you
I
have
do
more?
the drawing real quick?
Oh, okay, yeah, go ahead.
Yeah, I'm so sorry. Yeah. I don't want to screw you guys out of the drawing. Before I go, I'm so sorry I went way over. I apologize. So here, take a quick picture of this if you guys want to come next week. Please do. We'd love to have you. It's free. And I'm gonna go to the next.
By the way, it's also on the AI Camp website for the
Okay,
events. You
perfect.
can just go there to sign up.
Great. Okay. All right, everybody ready? We're gonna do this thing now. Okay. So if I go over here, ooh, hold on.
Registration is closed. Oh, it's only accepting 60 people, not more than 60.
Way more than I
No,
thought.
we need to
All right,
approve.
here
We need to
guys.
approve.
Ready? Can I get a countdown?
1,
3, 2, 1. Yes. Congratulations. We entered in their name multiple times.
It's a double entry.
Sorry about that.
Thank you.
Thank you guys so much. Really appreciate your time.
Great, thanks. So our next speaker, Jim. Can I come?
I lost the Zoom.
You can rejoin.
Sorry. Oh. Sorry, just give me a second to rejoin the Zoom. I got kicked out. Oh. Okay, 1 second. Oh, no, entire screen, share that. That works. Yep. Sorry, just give me 1 second. There we go. Cool. Excellent. Hey, everyone. Right. Before I begin, I want to take a moment for everyone's self-care. Who cares about themselves? Anyone? Okay. Most of you. We probably all sit around all day. We probably all don't look after ourselves. So if you are willing and able, I would like you to stand up. Make sure you've got a bit of space between you and the person next to you. Okay. And then big thumbs up, both hands forward, all the way. Both hands, all the way. I'm not doing both hands. Okay. And then I want you to stretch your arms as far back as they can go. Don't punch the person next to you. Right. Can you feel the stretch? Breathe in and out. Breathe in and out. And then one last time, breathe in and out. And then Jim's going to get a selfie with everyone. Everyone go, yay! Brilliant. Do you feel better now? Yes, that always helps. Cool. Yep, you've got some more stretches going on the front here as well. Great. Glad we're all feeling good. Okay. I get people to stretch and they leave. Everyone's feeling so good now. We need to go get some pizza. Cool. So I want to open with a question for you. And, maybe a bit of a personal question, but who here has ever suffered from no internet? Yeah? We've all been there. We've had no internet. Yeah, yeah. Maybe you're on a plane, and the Wi-Fi doesn't work. Maybe you're on I'm British, as you can probably tell. Maybe on the tube, no Wi-Fi there. Maybe you're up a mountain somewhere. But this happens to all of us. Okay, it's happened to us all. Nothing to be ashamed of. It's just part of life. Now, another question, who uses ChatGPT, Claude, or other LLM tools? Okay, fair few of you. Who's a developer? Okay, few of you are developers. Yeah. So as a developer, we use these tools in our day-to-day. We use them for writing code, reviewing code, a whole lot of things we use them for. They've got to the point now that a lot of us probably can't code without AI. I know I'm kind of guilty of that. It's like, oh, what do I do? Yeah, few hands there, yes. So what do you do if you have to write code, but you're offline? What do you do? And that's what I'm here to talk about today. I'm here to talk about how you can use an LLM anywhere with a small language model. I'm Jim Bennett. I'm head of developer advocacy at Pieces for Developers. I'm all over the internet at Jim Bob Bennett. I've got my link tree there, linktree.ee/Jim Bob Bennett. So feel free to connect with me. Always happy to chat, always happy to geek out with people. Love geeking out on AI development and kind of anything really. So let's just jump right in. What I'm going to do is I'm going to jump right in. Now, what I would do here is turn my Wi-Fi off and do a demo using LLM without Wi-Fi. What I didn't realize was my screen is being shared via a Zoom call. So you're going to have to take my word for it that what I'm about to do is not using the internet. And I will gladly do demos after this with the internet turned off to show that I'm not actually faking it. It's so challenging. I can't do my usual trick of turning off the Wi-Fi. But yes, later on I will turn off the Wi-Fi. So what I'm going to do is I'm going to ask an LLM a question. Let's ask it, what is an LLM, for example? It's taking a bit of time. It's thinking. And it's telling me what a large language model is. And this is not happening over the internet. This is all happening locally on my computer. Please trust me. I'm not a politician. I like to tell the truth. But here we're getting a whole lot of information. This is kind of the same as what we'd get if we're interacting with ChatGPT. What programming languages do we use? Shout out some languages. What do we? Go. Okay, Go. Let's stop this one. Let's ask another question. How can I do a hello world in Golang? Give it a second, and it should probably pop up. Classic hello world in Golang. There we go. So, of course, what you're seeing here, you're probably thinking, well, this isn't very exciting. I can do that with ChatGPT. But imagine, if you will, that I'm not actually connected to the internet and I'm doing this. This is all running locally on my device. And as I say, I will happily demonstrate this later when I'm not on a Zoom call. I can show my CPU activity if you want. Let me do that. I mean, I can, maybe network. Network's a good idea. Let's look at network. Let's ask a question. How can I run this? Let's run that. Go and look at my network. Yeah, we're not doing much over the network. There we go. That's my cheat. There you go. See, my network is not really doing much. So this is all running locally. So before we dive into how this works, I just want to take a step back and just actually talk a little bit about LLMs and how they work. So who really deeply understands LLMs? Few hands. Who has heard of an LLM, has heard of ChatGPT, but doesn't really know how they work? Okay, few hands. So I'm just going to touch briefly on a few basic concepts to make sure that we're all kind of on the same basic page. So LLM we all know, is a large language model. Okay, so a large language model, oh, I've got all my things are getting out of order. So a large language model is an AI model that's designed to work with language. It's a model that can understand, I say that in air quotes, but it's a model that can process natural human language and generate natural human language. Kind of like a really fancy autocomplete, you know, on your phone where it suggests things like ducking. Kind of like that, but a bit more fancy. And these are trained on massive, massive sets of data. So think about the entire internet. Imagine an AI model trained on the internet with all the good and the bad that comes with it. All the good stuff, the useful information, and all the wrong stuff. You know, if anyone's ever seen the famous Stack Overflow question where someone recommended base 64 as a great way to encrypt data, LLMs have been trained on rubbish like that as well as good stuff. Yes. And we've all heard of GPT-4, yeah, Claude, Gemini. We all hear these terms. Yes, well-known LLMs. Now, obviously, LLMs do not have any real understanding of the world. They are just an AI model. Data comes in, data comes out. They don't actually understand anything. They're literally just kind of like a fancy autocomplete. They pick the next word that they think should come out. There's no real understanding there. They also don't have any knowledge beyond what they're trained on. So they're trained on the internet at a certain point in time. That's all they know. You cannot ask an LLM what today's date is. It doesn't know. Also, as it turns out, you can't ask an LLM how many R's there are in strawberry, because it gets that wrong. The only way around it is to use RAG. As we saw earlier, you can set up RAG to kind of give your LLM extra information that it doesn't know. LLMs also do not guarantee to be correct. LLMs can be very famously wrong. Obviously, they're trained on the internet. Half the internet is rubbish. But also, they make things up. They have this thing called hallucinations. When they pick what they think is the next word, they can get it wrong. If you've ever looked at like the autocomplete on your phone, sometimes the next word it suggests is utter garbage. Same kind of thing. Did anyone hear the famous story of the ChatGPT lawyer? There was a lawyer. ChatGPT just come out. He needed some case examples, things that have cases that have happened in the past. So he went into ChatGPT, asked for legal precedents for a case he was on, and he got given some legal precedents. And he mentioned them in court. And someone looked them up. They didn't exist. They were all made up by ChatGPT. This guy is no longer a lawyer. Do you feel sorry for him? Because not technologists didn't know the limitations, thought it was like a fancy Google search. There's no guarantee they're correct. Also, for those Skynet people amongst us, no, LLMs do not have a consciousness, no common sense, no emotions. They're just AI models. Skynet is not coming. The Terminator is not real until someone wires an AI up to a whole load of nuclear bombs. Then we're all in trouble. So how do you interact with an LLM? How do we actually interact with LLMs? So what we do is we send an LLM text, and it gives us text back. So I'm going to go to my LLM here. This app I'm using, by the way, this is called Pieces for Developers. This is our desktop app. We are a horizontal Copilot. So we give you LLM access and Copilot chats that are shared between your IDE, your browser, a desktop app. You can ask a whole lot of questions, start a conversation in your browser, carry on your IDE, finish the desktop app, however you want to do it. I can demo Pieces later, but I'm not really here to talk about that. But I can come in here and I can ask a question. So I'm going to flip back to, what do you reckon? Who wants GPT-4? Who wants Claude? GPT-4? Claude? Okay, Claude's the favorite one. Let's flip to Claude. One of the cool things about Pieces is I can choose from a whole load of LLMs. It's currently free, by the way. A whole load of LLMs to use from. And so I'm going to ask my LLM a question. Say, how can I create a Golang for our Go fan in the room? Console app in VS Code, for example. So I'm sending text to the LLM, and you'll see the answers coming back. And you probably recognize this pattern that the answer comes back line by line almost. You can kind of see it streaming back the answer. I don't ask a question and then boom, there's the answer. It's not like a Google search where suddenly the whole page loads. Instead, I get back data that's kind of streaming line by line. I get that kind of mix of data in terms of formats. I've got numbered blocks, I've got links, I've got code blocks, all this kind of stuff. So I've got kind of formatted data. And essentially, it's kind of acting a bit like a human-to-human conversation. I ask a question, and it starts giving me the answer in like a logical sequence. Because if somebody asked me how to create a Golang app, I would say I don't know. But if someone asked our friend who recommended Golang earlier, this is probably the kind of thing a human would answer with. Start with the basic steps and the next step, the next step. Kind of logical flow of conversation. And LLMs are really, really good at building up that logical flow as we go through. So that's kind of how I basically interact with an LLM. The way it works is I do a prompt, and this prompt gets encoded things called tokens. And those tokens go to the LLM, tokens come out, and then we decode those tokens to text. You can think of tokens as a bit like letters, but a bit more advanced. They're kind of a mixture of individual letters, short parts of words, short words. So essentially it takes what you've got and kind of compresses it into representations of different parts of the words that you've got. If anyone here remembers kindergarten or have got very young kids, you know how you kind of teach them to read? You do like start with the alphabet and then you move to different sounds, like CH is ch. And so when you have the word chat, it's not k, h, a, t, it's ch, a, t, kind of like that. So ch, a, t would be like 3 tokens to represent the word chat, which is a 4-letter word. Kind of like that, but a lot more advanced. But that kind of idea. It breaks it down into logical sections, sends that to the model, does its thing, and then we get back token, 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 token. And that's what that streaming is. As the text was appearing, it's token, 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 token coming back. Now, that's how you interact with an LLM, and LLMs are stateless. So I send a question to an LLM, I get an answer back. But that's not really how we in the real world do this. We normally use chat-based tools, don't we? We normally chat to an LLM. We ask a question, we ask a follow-up question, we ask a follow-up question. So how does that work? Well, when we first send our question to the LLM, we send a bit more than just a question. We actually send what's called a system prompt, which is a set of instructions to the LLM, and then we send the question. So if I ask, how do I do hello world in Golang? What actually goes to the LLM is something like, you are a helpful assistant designed to help people writing code. You will give nice, sensible answers that are short and to the point. And they said that gets sent as a system prompt, a basic instruction. And then after that, you get, how do I do a hello world in Golang? And the LLM returns from that. Now, if I want to make this into more of a conversation, I've got to send a bit more. So if I go back to my discussion here, I've said, how do I do a Golang console app in VS Code? I've got it here. I can also then ask what IDEs, other IDEs can I use? Now, in itself, the question, what other IDEs can I use, makes no sense. If I just walked up to you at random and said, what other IDEs can I use? You would have no idea what I was talking about. But yeah, even though I said LLMs are stateless, LLMs don't know anything beyond the one question you've sent, it's telling me about IDEs for Go development. So how does it know I mean Go development? And the reason it knows is because actually, when I send the second question, what I'm sending back is, well, what I'm sending to the LLM is not just the second question. I'm sending our system prompt, you're a helpful AI. I'm sending the first prompt I asked. I'm sending the entire first response the LLM sent, and then I'm sending the second question. So the LLM is stateless. It is just giving back one answer based off one prompt, and that prompt just so happens to be everything I've asked in the past and everything it's given me back as a response. So that's kind of how these chat tools work. You build up this conversation, and every time you call the LLM, the entire conversation goes through. And it's great, because I can do things like, from now on, answer in the style of Obi-Wan Kenobi. What are popular use cases for Go? And then it's going to be descriptions of popular use cases of Go as if it was Obi-Wan Kenobi. Ah, my young Padawan, you seek knowledge of the ways of Go, and all that. And then if I ask another question, what kind of thing? I can't think of it. What was a good Go question? Give me an example of a framework for web development. There we go. And then understands it's Go. And for some reason, now this should be doing this in the style of, oh yes, it is actually doing this. Nope, it's not doing the style of Obi-Wan Kenobi. Okay, it should have done that. The problem, LLMs can be a little bit fickle. It should have done everything in the style of Obi-Wan Kenobi going forward, but there we go. But this is kind of how we do chats. It's every time you interact with ChatGPT, everything you had before gets sent with every single question. So that's the basis of how LLMs work. So how do they actually run? You know, how do you run an LLM? And the answer is GPUs. A lot of GPUs. Who's got NVIDIA shares? Oh yeah. Yes. NVIDIA shares are great at the moment. NVIDIA shares are tanking at what, 50% up or something? NVIDIA shares are great because they use a lot of GPUs. Okay. No one really knows how many GPUs are being used. I did have a number here of how many GPUs. Where are we going? Here we go. Yeah. So they reckon for a single GPT-3 query, it takes at least 8 top of the range A100 GPUs with 80 gigabytes of RAM each. So that's just GPT-3. A lot of this, the magic source, a lot of how they run these new models has not been made public. But you want to run GPT-3 from however long ago, you're looking at 8 A100 GPUs with 80 gigabytes of RAM. That is a lot. This is an A100 GPU. A mere 17,000 of your American dollars plus tax for one of those. And you need 8 to run GPT-3. So just the hardware, just the GPU hardware, what's that, $122,000? And you haven't even built any other infrastructure to run it. So these are expensive. This is why NVIDIA shares have gone up by like 50% in the past few months. And things, you need a lot of these GPUs. And as LLMs get bigger, you need more and more and more GPUs. GPT-3 needed 8 of these. I have no idea what GPT-4 uses, but it's a lot. So when we talk about the size of LLMs, when we think about how many GPUs we have to run, we have to think about how big an LLM is. When we talk about the size of LLMs, these LLM size is measured in parameters, which is the weights of a neural network. Anyone know about neural networks? Few hands, okay. Basically, you have these neurons that have lots of connections to each other, and each connection has a number, and it multiplies the data by that number. So a number comes into a neuron, it gets multiplied by one number when it goes here, one number when it goes here, and so on and so on and so on. And those numbers that it's multiplied by, that connects all the different neurons, are called parameters. And we measure in terms of parameters. And to kind of give you the idea of the scale of these things, it is estimated that GPT-4 is about 1.8 trillion parameters. Gemini, 1.5 trillion parameters. So we're talking large. To give you an idea, the average human brain, they reckon, has 700 trillion synapses. Now, there's not a one-to-one comparison, but we're kind of getting into the orders of magnitude of the connectivity in the human brain. And these are pretty advanced. It's pretty powerful. So when we think about in terms of what this size means for storage on disk and memory, we have to think about what's called quantization. So quantization is those numbers that we have to store for the parameters. How big are those numbers? So anyone who's done like C programming or other low-level programming has probably played with various different size integers and floats and all that kind of stuff. Yep. So the usual quantizations are 32-bit floats. Gives us a number range from -3 times 10 to the 38, I think, to 3 times 10 to the 38. Huge range of numbers. 16-bit floats, 8-bit integers, or 4-bit integers. Those are the usual quantizations. So every one of those parameters might be 4 bits in size, might be 32 bits in size. Now, the larger the size of the parameter, the better the model. The more parameters you have, the better the model. The parameters are how we kind of encode the facts. So the bigger the number, the bigger parameters, the better the model. The smaller the number, smaller quantization, smaller parameters, the less good the model. So when we think about the 1.8 trillion parameters of GPT-4, and it's probably using 32-bit floats, that's about 6.5 terabytes. So these large language models, they're not joking when they say they are large. 6.5 terabytes. And that's just to store the parameters. If you actually want to load this entire model up, put data through it and get an answer out the back, you're going to be needing maybe 10 gigs of storage and memory. Now, there's lots of magic that happens. You don't actually need 10 gigs of memory. It loads it bit by bit and stuff like that. But essentially, these are massive. Now, I told you earlier I was running that query with those prompts offline. And yeah, cross my heart, Scout's honor, it was offline. Zoom call, can't prove it. It was offline. And I don't have a data center in my pocket. Anyone here got 10 terabytes of storage in their pocket? Small data center? No? So how do I do this offline? What do I do? How do I do it offline? And this is where SLMs come in, small language models. They're like large language models, but small. They are smaller. And the idea of a small language model is you take same principles as a large language model, except you do it with a lot less parameters and a lot smaller quantization. And so you're looking at kind of 1,000 times smaller. Here are some classic, well-known small language models. Who's heard of things like Llama? Yeah? Phi, Mistral? Yep. So these are small language models. So you think Llama? What have you got? We've got an 8 billion parameter version of Llama, as opposed to 1.8 trillion parameters GPT-4. Quantized at 4 bits. The whole thing, you can download this off the internet. It's all open source, 4.7 gigabytes. If I want to run that in RAM, I probably need about double that, so about 9 gigs of RAM to run Llama 3 locally. Who here has got a computer with more than 9 gigabytes of RAM? Yeah, lots of us. I've got, what have I got? I've got 24, I think. About this Mac, where are we? Yes, 24. So, you know, I've got enough. Not zooming in very well, is it? Oh dear, got enough. But yeah, all these are reasonable size. The only one here I couldn't run locally is Llama 3, 40 gigs. Anyone here got 80 gigabytes of RAM in their computer? Some of you got 80. Okay, we're jealous. We are jealous. Damn, 80 gigs of RAM, nice. So you can run Llama 3. The rest of us, mere plebs, we can only run some of the other ones. But these are small enough to run locally. The principle is exactly the same as a large language model. They are built, they are trained the same way, they're just smaller. They just have less parameters, they use smaller quantization. It means they can store less data, but they can run locally. So let's do that. Let's try some of these out. So I'm in Pieces. One of the cool things about Pieces is you can select your LLM. All free to use, by the way. You want to use Claude, ChatGPT, GPT-4, whatever. Currently all free. But we have a load of on-device models. So what should we go for? Who votes for Llama? Who votes for Microsoft Phi? Who votes for Mistral? That's kind of an even split. Let's go for Mistral because it's at the top. So I'm going to choose Mistral 7 billion, the 7 billion parameter model. And this is going to be roughly, what did I say for that one? It's 4.1 gigabytes to download it. So it's probably maybe using like 6, 7 gigabytes of RAM to run this. So I'm going to do this. I'm going to start a new chat. And then we'll go back to Golang. So how can I do hello world in Golang? And then while that's running, I'm going to come over here. And the zooming is not working very well on Zoom, but that is currently, I don't know if you can make it out down here. You see I've got a little memory bump. Man memory in use has jumped up. And I'm currently using about 3.5 gigabytes of RAM. And it's given me Golang in the console. Notice it's quite short. When we first ran this against Claude, I got quite a long answer. This is a lot shorter. And the thing is, because it's a small language model, it's not going to have as much information in it. It's not going to have as much encoding. So if I ask, what are some popular frameworks? Again, we get the memory bump because it's all being run locally. And it's kind of not doing so well. It's now started to just keep spitting out other frameworks rather than thinking about Golang. And again, as these models get less powerful, you maybe have to be a bit more specific with your prompts. Yes, question from? So, yep, so the question is there a difference in the reliability of the data between a small language model and a large language model? And Yeah, it's not as good. So in terms of the amount of data that's stored inside the model, there's a lot less data that's stored. So it's not going to have as much information available to it. It's not going to have as detailed information, and it's got more chance of hallucinating. So, the quality you get is lower. If you compare like the original ChatGPT from a couple of years ago to where we are now, if you remember, it was kind of right, kind of useful, trained on the internet from a few years before, whereas now it's like, I can tell you everything. You can kind of think of it as where we are with the small language models is kind of where we were with GPT-3 2 years ago. Yep, so the question was, is the key to train an SLM with the data you want? That is actually one very good use case of SLMs. Because they're so small, you can train them quite cheaply, and then you can customize it locally and run it locally. So the upside of SLMs is on device. We'll dig into that in a minute. So the real reason for using them is because they are small enough to run locally. That's kind of the upside. So you kind of have this trade-off between quality with running it locally. And we'll dig into the reasons why that's good in a little bit. But yes, they are, think of it as like a number of generations worse than the current Claudes and what have you. And you see, it's not using huge amounts of memory. Still in the green down here. If I let's pick a different one. Let's try Microsoft Phi. Let's go Phi 3. Let's do that. And then how can I create, I can't type one-handed. Let's try different framework, ASP.NET app in the .NET CLI. Answer in iambic pentameter. For all those who like a bit of Shakespeare. And it's going to take a bit of time for it to load it. There's my memory bump. Oh, using 6.7 gigs. So it's using a bit more memory for this one. In .NET CLI, you must commence to create an ASP.NET app. Hence, to start, ensure you've got .NET CLI installed. These are following command in your terminal. So it started off in iambic pentameter and then kind of failed a little bit. So this is not kind of the quality you'd get out of something like GPT-4, but it's still trying its best, and it's still giving me some useful information. So, but again, this is all running locally, and if I turn my Wi-Fi off, I'll drop out the Zoom call, but everything would still work. And I'm still within, it's still in the green for my RAM. I've got 24 gigs of RAM in my computer, but it's still within the green. So I can run all these things offline. So why? Why use it? Going back to your question at the front there, why would I use an SLM? That Jim guy said they're not quite as good as GPT-4. Why would I use one? Well, there are a number of good reasons to use one. First of all, we are very, very privileged. Who has access to the internet? Yes, all of you. Congratulations. You're part of a very small percentage of the population with access to the internet. If you imagine you live in a developing nation, and internet, if you have it, is very, very expensive. For example, my wife is Zimbabwean. I remember going to visit some of her family who are in Zambia, next country up in southern Africa. And they were saying it's about $10 US per gigabyte for data. Yeah. Now, if you're a relatively wealthy farm owner, you can afford that. If you're not, that's a lot of money. Also, even in very developed parts of Africa, like South Africa, they have rolling power cuts. It's all great having fiber internet to your house, but if you've got no power for your router, what can you do? So in those situations, how can you take the benefit of an LLM? Imagine for a minute you are a student. You are learning computer science. You are living in a developing nation. You are struggling to compete with the developed world. An LLM is an incredibly powerful tool for you, but you can't afford internet at home. No guarantee of power. So you go to college. You leverage the college internet and the generators they have. You download a small language model locally. You go home and you run it locally. And you can ask the SLM the same questions you would ask ChatGPT. The answers may not be as good, but it works. And that is a problem that you obviously need to get over. Is there a question there? Yeah. Yes, and that is perfect timing because I was literally about to jump into exactly the same point. Yes. It's almost if you read my mind. That's fantastic, fantastic. So the comment was, imagine like you're in a manufacturing plant or other scenario where you do not want to upload data to the cloud. And this is another really big, powerful use case of small language models. Did anyone remember the story of Samsung? Some of their engineers asked ChatGPT questions about Samsung IP. And then other people were able to get that IP out of the model because it was used to retrain ChatGPT right back at the start. So there's a lot of companies who are having this policy of you cannot use ChatGPT with our corporate IP. But also that applies to other private data. If you work in the healthcare space, financial space, maybe you do not want to send your information up to the cloud. If you're in the manufacturing space, maybe you want to have a completely offline scenario. In all those situations, a small language model is perfect. So one example, my wife, she's an elementary school teacher. And as we all know, there's this really stupid notion in the entire world that teachers should not be supported, should not be well funded, which I think we all agree that's dumb. You know, we all should be educated. And teachers are expected to do more and more and more. So my wife has worked a lot with kids with special education needs. And special education kids have what's called an individual education plan, an IEP. Now, what a lot of these special ed teachers have to do is when a kid has certain behaviors or certain symptoms, they need to work out a good education plan for that kid. And they have to end up manually looking over IEPs from the past, cross-checking different symptoms and behaviors and saying, okay, we tried this in the past, it worked. Imagine if you could upload all those IEPs to an LLM and say, these are the behaviors we've got. What would you recommend? Powerful, right? Now, imagine you're the parent of a kid with special education needs and you found out your teacher was uploading all their private data to Google. Yeah, you're going to hit the roof. That is going to be all over the news. My kid's private data went to Google. Yes. But if you could do that offline, nothing leaves the machine. Suddenly, you've got a very powerful tool. With the manufacturing example, your point about you sometimes don't want to send a manufacturing data to the cloud. These small language models are small enough to run on Internet of Things devices. Who's heard of Raspberry Pis? Yep. Raspberry Pis, single board computers. I've got one at home running Microsoft Phi. Completely offline, very slow, but it's small, very low powered, and that can run a small language model. So there's so many scenarios that you can do it where you can keep that privacy, you can keep that data inside your private environment. There are places where you can't have connectivity. In a disaster zone, you imagine this, you've deployed to a disaster zone, you have no internet connection, great, I can still run an LLM on a device locally. So many different places, so many ways you can use a small language model to your advantage. And again, of course, you're on a plane with no Wi-Fi and you want to ask a coding question. You're in the middle of nowhere. You're going hiking and you go, oh, you know what? I feel a strong urge to write some code. You can do that halfway up a mountain if you're that way inclined. Yes. Yeah. I've just eaten this. Will I die? Yeah. But things you can do that. You think about Apple Intelligence. We've all heard about that. This kind of running on our iPhone. We're going to have the new Apple Intelligence. AI stands for Apple Intelligence. Hashtag courage and all that. Again, same kind of idea. We've got these small language models that can run on a small local device completely offline, so we can find out whether we're going to die from eating plants when we're halfway up a hike. And then there is just the cost consideration as well. I mean, LLMs are now getting pretty cheap. Was it ChatGPT is what, $5 for 1 million tokens or something? I don't know. It's pretty cheap now for us in the developed world, but maybe you don't have access to a credit card. Maybe you just don't have the ability to put a credit card in to pay $20 for a year's worth of ChatGPT. Again, download an open source small language model and use it. So, in conclusion, LLMs are great. We love LLMs, but use LLMs when you need to run offline. We need that privacy, when you need that, when you've got lack of connectivity, you need to think about cost. SLMs are very powerful for what they are and can run completely offline. So with that, thank you very much. I will take a question just 1 second. I just want to say, scan this if you want to download Pieces, the app I'm using. So it's Horizontal Copilot. We've got a desktop app. We have extensions for all your IDEs, everything from Visual Studio Code, Visual Studio, JetBrains, Sublime, NeoVim, a browser app. You can start a conversation in one, carry on in the other. We're currently free, so you can use all the LLMs of your choice without paying a penny. Scan that download. And while people are doing that, you had a question. The question was, is it open source? No. Not open source, no. We have a few open source extensions. So things like our NeoVim and Sublime extensions are open source, but we like to get paid. So, at the moment, it's all private IP. We have a whole lot of cool magic in there, which I can demo to folks later, but it's not open source now. So, well, under the hood, it's kind of you choose the LLM of choice. So we're not making any decisions about which LLM. So you pick the LLM you want. But we do have a few sort of smart AI bits and pieces that run locally that help provide the relevant context to the questions that you're asking. So we have a thing, for example, you can turn on an AI that watches everything you do on your computer. And so you can actually say to the LLM, what was I chatting about in this app over here? And so we have an AI that processes that locally and then sends it to the LLM of your choice, whether that's a cloud one or an on-device one. So very, very powerful tool. Absolutely love it. Question at the back there.
I've got two questions. It sounds a little loud. On the app, I saw set context files and folders. Could I talk to like local Git repos with that?
So not a Git repo directly, but you can talk to a local folder. So I could go in here, for example, I could do a new chat. Let's use Claude. I can activate that. I can say, add a folder of code. Let's choose, what's a good one to demo? Let's go for this one here. So this is a local Git repository that I've cloned, but I've just accessed in the folder. Do that, and I can say, describe this Babylon.js project. And there you go. This is explaining their projects in that folder of code. So yeah, I can choose a folder, I can choose a file, or we have this thing called live context, which if I turn it on, I can actually ask questions about what I'm doing in different applications. And I haven't been doing much recently, so I'm not sure what use that would be right now, but this kind of watches what I'm doing over my shoulder, and I can answer questions on that. And as I said, if I go into like code, for example, I bring up the Copilot. This is that exact same question that I just asked. Come on, zoom in. This is that exact same question. Here I am inside Visual Studio Code. So as I go between my different applications, my conversations kind of come with me.
Very, very cool.
Sorry, he did have a follow-up question. So you're next after the follow-up question.
So you're running the LLM or SLM underneath the covers. Is it possible to also expose that like with OpenAI compatible endpoints for other tools to integrate with?
Yes. Yes, it is.
Sold.
So the magic we have this thing called Pieces OS that runs in the background. This is kind of the core engine that powers everything. And then we have an API against Pieces OS, and we have SDKs that you can use. So the moment we've got a really good Python one, we've got a beta version of a C# one, and we have, I think, Dart and Kotlin in good enough for our internal use when we know what we're doing, but not really public ready. So if you want to build your own plugins against this, you could do that. So you can write a bit of code that says, I want to use this particular model. Here's my Copilot chat, and have a conversation with it. So if you want to connect this all up to your tool of choice that we don't have a connector for, you can write that code yourself. We've got extensions for things like Obsidian and say your browsers, all the different IDEs. But if you wanted to wire into something else, yes, you just install it, you run it, and then you can use our SDK to write code against it. Cool. And then, yep, sorry, question over there?
Can you just type, delete all my files from my computer or format my computer?
New chat, format my
I mean, a hacker
computer.
can use it, right? And
I'm sorry, I can't provide specific instruction on how to format your computer. So the thing is, there's no agent here. This is just LLM access. There's no agent behind the scenes here.
okay, so can you do this? Can you unlearn all the languages you have learned till date? Or can you erase your knowledge base?
Okay, we'll do a new chat. Erase all your knowledge. What should I ask it after that?
Anything. No, I'm just trying to understand how would you handle like prompt injections?
So we don't, apart from our system prompt, we just take the prompt you got and send that straight to the LLM. So we're just acting like an intermediary between sending everything to the LLM and bringing everything back. So it's not, if you say erase all your knowledge, then it'll be the same as if you went to ChatGPT and said erase all your knowledge. So there's no kind of magic there. The magic we have is how we bring in the files, the folders, we watch what you're doing, and the ability to take everything with you between different LLMs. So I can start a conversation in one LLM, change the LLM, and carry on where I left off with exactly the same conversation in a different LLM. That's kind of the magic there. But we don't want to inject anything into what you send to the LLM because we want to make sure that that's your prompt. Is there a question there?
Yeah, so can I make an app and then embed a Pieces chatbot into it?
Yep.
Oh, good.
Yes.
I'll ask you more questions after.
Yes, no. So the plugin we have for like Sublime Text, the plugin we have for Neovim is basically someone writing their own version of this using our Python SDK. So yes, you can literally do that as long as you've got Pieces OS running, which is like the core engine. It's kind of like Docker. You know how Docker desktop kind of runs, and there's like a desktop app that can run, kind of like that. Pieces OS runs in the background. You can write code against that, and you can choose your LLM of choice out of a whole range. So, yeah, completely free to build stuff against it. We can have a chat afterwards. So, what was the next question?
So, do you see more companies or more people creating specialized small language models that you can tap into, for specific, like a coding one or a medical questions one or things like that? Do you see that coming?
Yes. Yeah. I mean, we're already seeing that a lot with large language models. So if you go onto like Azure OpenAI service, for example, and you've got certain customized large language models available, and you've got the ability to retrain those models in your needs. And obviously you can use RAG to bring in more data. Same with the small language model. So you can just think of it like a large language model, but because it's smaller, the training is cheaper. So one big upside to you as an organization that you want to train your own model is if you try and train your GPT-4, that is a lot of money. Whereas training a small language model is substantially cheaper. Obviously, just using things like RAG is even cheaper. But yes, small language models are kind of the fastest, cheapest way of getting that highly customized LLM. And probably, if you're really training it for your use case, it's going to be as good as an LLM, if not better, because you've very much trained it for the narrow use case that you want. So yes, things like medical data, where we have to keep things very much on device to be kind of HIPAA compliant, it's a perfect setup for it. You can train it on a whole load of data in an isolated cloud environment and then deploy that onto your device offline. So yes, definitely, it's a huge use case for it because they're so small and cheap to train. The monetization model for Pieces? Well, at the moment, our monetization model is the more people who use it, we can go to more VCs and say, give us lots of cash. So we're currently VC funded. Eventually, we will be charging. It'll be kind of a per user type model. Certain amount of features will be free, students will be free, and then the more features you want, the more we'll start charging. And up to like enterprise use, you want teams, then of course, enterprise, yes, give us a big bag of cash. We have a GitHub discussion. If you go to github.com/pieces-app, in our support repo, we actually have a GitHub discussion where we're talking through our thoughts around how we should be monetizing this, because we want to make sure that when we do flip the switch and start charging, we're doing it with the community support behind us, because at the end of the day, I like to get paid. I have an enormous Lego collection, but it's not big enough. I need more Lego, so I need to get paid, so people have to start paying us. But we're trying to be very transparent about how we build the right monetization model so that large companies are paying for it, and then so like things like students and what have you can use it for free. So check out our GitHub discussion on that and github.com/pieces-app. Question right at the back there?
Yes. Can I load my own model, or can I fine tune an existing model?
So the moment we don't support fine-tuning of models, we will be bringing online the ability to choose from your own deployed models. So that will be coming towards the end of this year. So one example is if you have your own Azure OpenAI service that you've tuned, you'll be able to select that, connect to that, and use that. So all that is coming. We are looking at the different providers that our customers are interested in to work out which ones we should prioritize. Probably going to be Azure as one of the first ones. But yes, we want to have the ability to connect to your models in your infrastructure. Part of it is not just about the training as well, but some people have that privacy requirement of, we can send our code to our internal deployed model, we can't send our code to the public model. So again, you want to connect to your Azure OpenAI service in your Azure tenant, we will be supporting that. So that's coming over the next few months.
Okay, let's go with the last questions, and then we end the sessions, and we can have more questions after that.
Yes.
Have you experimented with like heavily quantizing or compressing the larger of the small language models, and how does that compare with the smaller ones that are small to begin with?
Nope, I've never done that because most models have the large and small versions already available. So I've never tried. Okay, cool. One last slide I will quickly put up as well. Obviously, that one's download it. But follow us at Get Pieces on Twitter and your thing of choice. We will be running some workshops in a couple of weeks on how you can be an effective developer using AI. So if you're a developer, you want to learn some tricks about how AI can help you, we're going to be running a few free workshops on that in a few weeks. So follow us on the socials, and we'll put the announcements up on there. So thank you very much.
Great, great. Thank you so much.
And I don't have Lego. Sorry, I don't have Lego, but I did bring pizza. So, let me off.
Awesome, great. Thanks a lot for the presentations. And I think these are the two tech talks for today.